So we've got solving for angle measures, the step-by-step example. And so let's go. So the two labeled angles, I see these two angles make a straight line, so they would be either supplementary or a linear pair. I could say that either way. Linear pair is the option that I've got. And that means that their measures, a linear pair, is supplementary. So together they are going to make 180 degrees. How about that? Okay, so we're going to use this relationship to write an equation to help us solve for x. And so the way that I need to be thinking about that is that I need to understand that when I put those two angles together, they make 180 degrees. And so I've got 117 and 2x plus 7. So I'm going to have 117 plus the other angle, which is 2x plus 7. Those two angles together make 180 degrees. And so we can go ahead and solve this equation for that. So I'll just remove my parentheses to start with. And then I can combine like terms. So I see that 117 and 7 are like terms, which makes 124. And I still have my 2x equals 180. And then I need to solve this equation, so I'm going to subtract 124 from both sides, which is going to give me 2x equals 56. And then I see that I need to divide both sides by 2. And so I'm going to get x is equal to 28. So in GeoGebra here, GeoGebra, Wolfram, I'm saying everything except for what it is. This is Mathia, Mr. Schlegel. Okay, we're going to basically reproduce this equation and all the steps to solving it here in Mathia. So I'm going to have 117 plus 2x plus, must have hit something funky, plus 7. And I don't exactly need the parentheses in this, everyone. I'm just putting them for good measure. So that's what's up with that. So there's my equation that's going to work. And so like we did over here, our first step is going to be to combine like terms, the 117 and the 7. So we will click combine like terms. Then we had this right here equals 180. So 124 plus 2x is equal to 180 is already there. I made the mistake the other day of doing this, and it said that I was wrong because I didn't notice that equals 180 was already there. So we'll do that correctly. Now we said that we had an equation and we needed to do the inverse operation to get the x by itself, so we needed to subtract 124 from both sides. So we're going to subtract from both sides. The subtraction symbol is already there, so I just need to put in the 124. Next, they're basically simplifying this side of the equation, so 180 minus 24 is another way of combining like terms. And 180 minus 24 is 56. So lastly, we need to see that we need to divide both sides by 2, just like we did over here. And we get from Mathia that x is equal to 28, just like we did in our handwritten work. So Mathia is asking us to find the value of x and then use that to find the angle related, the size of the angles over here. So this is 117. We do have an x value in there, so I'm going to click that guy right there. Remember that this box will do the math for me. So I'm going to substitute 28 into my equation. So I'm going to have 2 times 28. One way to represent multiplication is with these parentheses. The other way is with the star above the 8. I could do 2 times 28 and then plus 7. And so it's going to figure it out for me just like a calculator would and tell me that that is 63 degrees. Let's go ahead and get started with the problems. I see that these two angles right here are labeled and they are vertical angles. So I'm going to say right away, those are vertical angles, I say. This means their measures are equal. So we know that vertical angles have measures that are equal. And we're going to use this information to write an equation for this one. So we'll pull this back up here. And we'll see that we have, instead of them adding up to 180 like this one did, the relationship here is that these angles are equal in size. And so we will have to say that the angle on the left is 4x is equal to the angle on the right, which is 104. So this is a much easier equation to solve than the last one. In the step-by-step example, we're straight up just going to divide by 4 on both sides. And we get x equals 26. So Mathia is going to do that as well in the equation solver over here. So we have 4x equals 104. We didn't need to combine any like terms. We just needed to divide on both sides. So we'll find that here on Mathia, divide both sides by 4. And we get 26 just like we did. So we can come over here, select the angle that we're looking for. We're going to substitute 26 in for this, and so it's 4 times x, which will be the equivalent of 4 times 26. It's going to be 104 also. Well, that's kind of a does statement, huh, because vertical angles are equal. Yeah, I could have thought of that one sooner. Okay, moving on with our lives, everyone. We see that we have something going on here. We've got, given that the measure of angle GIB, so GIB, the entire, both of these angles stuck together, measures 69 degrees. And these two angles, are they vertical angles? They are not. Are they complementary? It looks like they might make 90 degrees, but I don't have any evidence of that, so I can't say it. They're definitely not a linear pair. They don't form a straight line. And all I can say about them is that they are adjacent angles. This means that their measures, so these two angles together make angle GIB. And so angle GIB is 69 degrees, and so the measure of these two angles together sums to be 69 degrees. So writing an equation for this, I'm going to do it on the iPad first, and then we'll come back to the Mathia. So I'm going to have these two angles together make 69 degrees, and so I'm going to add them up. 23 plus 6x plus 1 equals 69. I can remove the parentheses, so I will have 23 plus 6x plus 1. Then on the left, I would combine like terms to have 24 plus 6x. Then I would subtract 24 from both sides. And I would have 6x equals 45. No? That's kind of odd, isn't it? 35? Oh, that's weird. Oh, I copied a 20. One moment. Yeah, 24. Checking my work in my head real quick, everybody. 24. Because we're going to end up with some kind of weird decimal or something on this one, and that seems strange. Let me pause the video for 1 second and check my work. Everything looks good to me, so we're just going to hope that our answer comes out correct, even though it's going to end up being a decimal. And we'll see what happens if it doesn't. So we'll have 45 divided by 6 as our last piece there. And that's going to come out to be some kind of decimal. I'll just leave it like that on my iPad for now and see what Mathia produces. So over here, we're going to have the equation that we wrote. It goes in Mathia. I'll go ahead and put it in without the parentheses. And our first step was to, from here down, to combine like terms. So getting the left side squared away there. So what we're adding together is the 1 and the 23 to make 24. Not 24. 1 plus 23 is 24, Mathia. Oh, oops. Duh. I need to put the 6x in there. So 6x plus 24. There we go. And the next. And again, you notice that these are backwards here compared to here, and that's fine because addition is commutative, meaning that we can flip things and they are still going to have the same meaning or value. And so here we subtracted 24 from both sides in our work. We're going to do the same thing on Mathia. Remember that our subtraction symbol is already there, so we don't need to type minus 24. We just need to put in 24. And then again, we're going to combine like terms just like we did right here, and we should end up with 45. And then we are going to divide both sides by 6. Mathia is going to tell me that 45 over 6 is how it's going to leave it. So that's awesome. We'll do the same on our work. Okay. So the x value is 45 over 6. And so we are going to be substituting that in for x here. So what we would have... Oh, and so I guess they want us to simplify. Next is the last piece. And so rewrite the fraction is what Matthew will have us do. And so 45 divided by 6. Shoot. Come on, Matthew. What is 45 divided by 6? Schlegel's got to get a calculator. I can't believe it. So the box in the solver is not actually a calculator. The box on the workspace itself is the calculator. So I get 7.5, everyone. And there we go. So now we're going to put 7.5 in for x. So we will have 6 times 7.5 plus 1. That box serves as a calculator. And that's got us all set for this particular workspace. Not workspace, for this problem. So I'm done. We're going to go to the next one. Hopefully this is the last one. So I see that these two angles together do form a straight line. That would make them supplementary or a linear pair. Both of those statements would be correct. Linear pair is the option we have available. Yes, I know, nice, huh? Okay. This means that they're measures. I put them two together and it makes 180 degrees. Okay. And so as we've done before, we're going to write an equation. We're going to write and solve an equation for this thing. So we've got those two together added up makes 180. So we can say 45 plus 2x equals 180. Because those angles form a straight line. Our first step in solving it is going to be to subtract 45 from both sides. We will have 2x equals 135. They like giving us fractional or decimal answers on this one, don't they? Last step, everyone, is going to be to divide by 2. And we will get x is equal to, I think it's going to be 77.5. So in Mathia, I will also throw that work. So we've got 45 plus 2x is equal to 180. Ding, 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 ding. I wonder if it's colored in all my circles. It has. Muy bien. All right. So what we need to do now, everyone, is subtract from both sides. We're going to subtract 45 from both sides. Remember, the subtraction symbol is already there. 180 minus 45, we need to combine like terms now. That makes 135. And then we will divide both sides by 2. Then I need to remember I can't put in the math to be done here. I have to do my math by hand elsewhere. Oh, it did it for me this time. Why didn't you do it last time, Matthew? What's up with you? Anyways, 67.5. My bad. Typo, Schlegel. 67.5. So our x value is 67.5. We can substitute that into the 2x. So we will have 2 times 67.5. That will do the calculation for me. And ding, 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 ding. Schlegel out.